Welcome. In this video, we'll solve a problem in kinematics related to concept of relative motion that can be solved easily using geometric ideas. Two airplanes A and B are traveling in perpendicular directions, each at distance 200 km from the intersection point. The velocity of A is 800 km per hour and the velocity of B is 600 km per hour. What will be the minimum distance between them? Give this problem a try. We'll try to solve this problem in two ways. In the first approach, we work in the ground reference frame. The idea is to compute the distance between the two planes as a function of time and then use calculus to find the minimum. As computing this minimum is complicated for the actual distance, we minimize the square of the distance. As the initial position of A is minus 200 km on the x-axis, its position xa is given as. Similarly, the position yb of B is given as. Using the Pythagoras theorem, we get the distance squared between the planes as. We get the following quadratic equation after substituting xa and yb. Now we differentiate this function with respect to time and set it to 0 to find the time when this function takes the minimum value. After differentiating with respect to time, we get the following equation. This implies that after 7 by 25 hours, the distance between the two planes will be minimum. When we substitute this time into the equations of the positions, we get the locations of the planes when they are close to each other. Therefore, the minimum distance is 40 km. This concludes the first solution to the problem. The second approach is to consider the situation from plane B reference frame. The initial position of A is minus 200 km along x-axis and 200 km along y-axis. The velocity of A with respect to B has component along the y-axis and can be written as the tan of angle alpha that the direction of this velocity makes towards B is 600 by 800. When we follow along this direction, the shortest distance between the two planes is the length of the perpendicular dropped from B to the corresponding line. Now consider the triangle A not AB. The minimum distance is distance AB times sine beta. The distance AB is 200 square root 2 times sine 45 minus alpha. We can expand sine 45 minus alpha as follows. As tan alpha is 3 by 4, sin alpha will be 3 by 5 and cos alpha will be 4 by 5. This gives the required distance as 40 km. As you see, in this frame, all the equations are simpler. If you like this content, please like, share, and subscribe. Thank you for watching. See you in next video.